Here are 10 space stories you can listen to in English. Now, let's get started. 8-minute-old sunlight. Did you know that if the sun were to suddenly vanish, we wouldn't realize it for over 8 minutes? The sunlight we see and feel at any given moment was actually emitted from the sun approximately 500 seconds, or 8 minutes and 20 seconds ago. This delay is due to the finite speed of light and the vast distance between the sun and Earth. Light travels at about 300,000 kilometers per second, and it must traverse the average distance of 150 million kilometers to reach our planet. Consequently, every sunrise we witness is an event that already happened in the past, and we are perpetually observing an 8-minute-old version of our star. This time lag isn't limited to just light. It applies to all forms of information and energy from the sun, including gravity. According to Einstein's theory of general relativity, gravitational effects also propagate at the speed of light. This means that if the sun were to disappear, the Earth would continue its orbit around the now empty point in space for that same 8 minutes and 20 seconds before the loss of gravity would cause it to fly off into space in a straight line. This principle is a fundamental aspect of physics, illustrating that no information can travel faster than the speed of light. Diamond rain on Jupiter. Can you imagine a planet where it rains not water, but solid diamonds? According to scientific theory, this spectacular event may be occurring deep within Jupiter's atmosphere. In the upper layers of the gas giant, intense lightning storms break down methane gas into its component atoms. This process releases carbon, which initially forms soot particles. As these particles fall deeper into the planet, they are subjected to immense increases in pressure and temperature. At a depth of approximately 16,000 kilometers, the conditions become so extreme that the carbon is compressed into diamonds. It is theorized that this process could be creating around 1,000 metric tons of diamonds each year. It is crucial to note, however, that this phenomenon of diamond rain has not been directly observed and remains a compelling scientific hypothesis. The theory is based on sophisticated computer models of Jupiter's atmospheric conditions and data from laboratory experiments that simulate such extreme environments. Currently, humanity does not possess the technology to send a probe deep enough into Jupiter's crushing atmosphere to confirm the presence of these falling gems. Therefore, while the underlying physics is considered plausible, the idea of a perpetual diamond shower on Jupiter is a prediction based on theoretical models awaiting future observational proof. Floating planet Saturn. If a bathtub large enough to hold the planets existed, which one do you think would float? The answer is Saturn, the second largest planet in our solar system. It holds the title for being the least dense planet with an average density of only 0.69 grams per cc. This is approximately 70% of the density of water. The reason for this remarkable lightness is its composition. Saturn is a gas giant made up primarily of the lightest elements, hydrogen and helium. While it is believed to have a solid rocky core at its center, with a mass comparable to that of the entire Earth, its vast gaseous atmosphere makes its overall density incredibly low. Of course, this is purely a thought experiment, as no body of water large enough to test this hypothesis exists. It's also important to understand that Saturn is not a uniform solid object. The concept of it floating refers to its average density. The planet's core is extremely dense due to immense pressure, far denser than water. However, the sheer volume of its massive, low-density atmosphere of hydrogen and helium gas significantly brings down the planet's average density. It is this gaseous envelope that would give the planet buoyancy, allowing the celestial giant to theoretically float on water. Venusian Acid Rain. Have you ever imagined a world where it rains acid, but the rain never touches the ground? On Venus, this is a reality. The planet is shrouded in an unbroken 20-kilometer-thick layer of clouds composed not of water, but of sulfuric acid, formed from sulfur dioxide and water vapor. From these clouds, droplets of highly corrosive sulfuric acid fall towards the surface. However, this potent rain never completes its journey. Due to Venus's extreme surface temperature, which averages a scorching 465 degrees Celsius, the acid droplets completely evaporate long before they can reach the ground, creating a cycle of precipitation that remains entirely within the upper atmosphere. These inhospitable clouds are also the reason for Venus's brilliant appearance in our sky. The sulfuric acid clouds are incredibly reflective, bouncing approximately 80% of the sunlight that strikes them back into space. This high albedo makes Venus the third brightest natural object in the sky, after the sun and the moon. It is this intense reflectivity that allows us to see the planet so clearly from Earth, where it is famously known as the morning star or the evening star. Ancient Martian Ocean, Mars, now known for its arid, dusty landscape, may have once harbored an ocean vast enough to cover its entire surface to a depth of 137 meters. Approximately 4.3 billion years ago, scientists believe a massive body of water covered most of the planet's northern hemisphere. This ancient ocean is estimated to have contained a volume of water greater than that of Earth's Arctic Ocean. This theory is based on geological features resembling ancient shorelines and the analysis of the ratio of different hydrogen isotopes in the Martian atmosphere, which provides clues about historical water loss. While the majority of this water has since been lost to space, significant remnants are thought to persist today. Evidence suggests that a considerable amount of water is locked away as ice within the polar ice caps and in subsurface reservoirs. The existence of this frozen water is a critical factor for future human exploration of Mars, as it could potentially be harvested as a crucial resource for drinking, creating breathable oxygen, and producing rocket fuel, thereby supporting a long-term human presence on the planet. Saturn's polar hexagon? Did you know that a colossal, six-sided jet stream large enough to contain 2 Earths exists at Saturn's North Pole? This atmospheric phenomenon, known as the polar hexagon, spans approximately 30,000 kilometers in diameter. This weather pattern has been remarkably stable for at least 40 years, since it was first clearly observed by the Voyager spacecraft. Its sides are almost perfectly straight, and the entire structure rotates at a speed nearly identical to the planet's own rotation, creating a bizarrely geometric storm system unlike anything else in our solar system. The precise reason why this vortex maintains its distinct hexagonal shape remains an unsolved mystery. The leading hypothesis suggests that it is a type of standing wave in the atmosphere, created by differences in the speeds of various atmospheric flows at different latitudes. Scientists have attempted to replicate this formation in laboratory settings by rotating a circular tank of fluid at varying speeds, which has successfully produced similar polygonal shapes. While these experiments support the standing wave theory, they have yet to fully explain the perfect geometry and long-term stability of Saturn's magnificent hexagon. Sideways planet. Can you imagine a season that lasts for 42 years? On Uranus, this is a reality. as it is the only planet in our solar system that essentially spins on its side. Its axis of rotation is tilted at an extreme angle of 98 degrees, meaning it rolls along its orbital path around the Sun rather than spinning like a top. This unusual orientation leads to the most extreme seasons known. For 42 consecutive Earth years, one of its poles is pointed directly at the Sun, experiencing a continuous summer, while the opposite pole is plunged into a 42-year-long winter of complete darkness. This dramatic tilt is not a feature Uranus was born with. The leading scientific theory suggests it was caused by a cataclysmic collision with an Earth-sized celestial body in the distant past. This colossal impact is believed to have been so powerful that it literally knocked the planet over, forever changing its orientation. While this impact hypothesis is widely accepted as the most plausible explanation, it remains a theory about a violent event that occurred billions of years ago, shaping one of the most unique characteristics found in our solar system. Vast yet thin rings. What if you could see an object stretching 280,000 kilometers across, yet being only about 10 meters thick on average? This is the reality of Saturn's magnificent rings. While their vast diameter is impressive, their most astonishing feature is their extreme thinness. Their proportions are often compared to those of a compact disk. The rings are not solid structures, but are composed of countless individual particles, with 99.9% being pure water ice. These particles vary dramatically in size, ranging from microscopic dust grains of a few micrometers to massive ice chunks as large as 10 meters in diameter. Contrary to the long-held belief that the rings are as old as the planet itself, recent data suggests they are a relatively new cosmic feature. It is now estimated that they formed less than 400 million years ago, making them much younger than Saturn. This theory is supported by their brightness. If they were billions of years old, they would have been significantly darkened by dust and debris from micrometeoroids. This youthful age implies that the brilliant rings we admire today might be a temporary spectacle, a fleeting phenomenon in the long history of our solar system. Blue Martian sunset. Did you know that while sunsets on Earth blaze with red and orange, those on Mars are a cool, ethereal blue? This counterintuitive phenomenon is due to the fine dust particles suspended in the thin Martian atmosphere. These particles are the right size to scatter red light forward, away from the sun, while allowing blue light to penetrate more directly. As the sun sinks toward the horizon, its light passes through more of the dusty atmosphere. This causes the blue light to be scattered forward in the direction of the observer, creating a distinct blue glow around the sun's disk. This blue color is most prominent near the sun itself. Interestingly, during the day, the Martian sky is not blue, but a pinkish red or butterscotch color. This is because these same dust particles scatter red light throughout the sky, dominating the daytime view. The blue effect only becomes apparent at sunrise and sunset, when the sunlight travels a longer path through the atmosphere. This extended path filters the light, and the forward scattering of blue light by the dust, a process known as me-scattering, becomes the dominant visual effect, painting a uniquely beautiful and alien sunset. Global dust storm. What if a single storm could engulf an entire planet for weeks at a time? On Mars, this is a recurring reality. The red planet is known for its frequent dust storms, but every few years, a much larger event known as a global dust storm takes place. These colossal storms can grow so vast that they completely envelop the planet in a thick haze of reddish-brown dust, a process that can last for several weeks and obscure the entire surface from view. These planet-encircling storms represent one of the most significant risks for Martian exploration. The dense dust veil blocks a substantial amount of sunlight from reaching the surface, causing temperatures to drop and, more critically, preventing solar-powered rovers from generating electricity. This can jeopardize the survival of robotic missions, as seen with the Opportunity rover, which ceased communications during a global dust storm in 2018. Consequently, understanding and predicting these massive weather events is a crucial challenge for the safety and success of future human and robotic missions to Mars.